Sure thing. Let's go from the top and dive into each topic one by one. I'll start now with SO1, Storage Integration Object. What is it? A storage integration is a Snowflake object that acts like a secure bridge between Snowflake and cloud storage, like S3, Azure Blob, or GCS. It lets Snowflake read or write data from to cloud storage without requiring you to manually manage access credentials. So instead of embedding access keys in SQL, you define a trusted connection once, and Snowflake uses that securely behind the scenes. Why use it? No exposed secrets. You avoid hard-coding credentials. Secure and centralized. Permissions are tightly scoped and controlled. Essential for external stages. It's required when setting up stages for automatic data loading, like SNOWPIPE. Example, create storage integration for AWS S3. You can see the code in our conversation history. After that, you also have to configure the AWS role to trust Snowflake using the external ID from desk integration and allow access to the right bucket paths. Ready for the next one? Should I move on to stage objects?
Yes.
Great. Let's go to the next topic. 2 stage objects in Snowflake. What is a stage? A stage in Snowflake is a temporary or permanent holding area for data files before they're loaded into tables or after they've been unloaded. So think of it like a buffer or landing zone. There are 2 kinds, internal, managed by Snowflake, and external, your cloud storage like S3 or Azure Blob. Types of stages, internal stages. These are fully managed by Snowflake. No cloud setup needed. Personal storage for each user. Table state, table name, automatically created for each table. Named internal stage, custom reusable internal stage. External stages. These point to your cloud storage, S3, Azure, GCS, using a storage integration. Example, creating an external stage. You can see the code in our conversation history. This connects to an S3 bucket and uses the previously created storage integration for secure access. Example, creating an internal stage. You can see the code in our conversation history. You can upload files to this using SnowSQL's put command. You can see the code in our conversation history that uploads local files into Snowflake's internal storage. Listing and using files. See what's in the stage. You can see the code in our conversation history. Load a file from stage into a table. You can see the code in our conversation history. Should I go ahead and explain SNOWPIPE next?
You didn't mention regarding the put and the get command.
Good catch. Let's add that in before moving to SNOWPIPE. Chash, put, and get commands for internal stages. These commands are used with SnowSQL, Snowflake's command line tool, to move files between your local machine and internal stages. Put, upload local files to internal stage. Use to upload files from your machine into an internal stage, like this. You can see the code in our conversation history. Overwrite equals true, replaces the file in the stage if it already exists. Remove false, keeps the file on your local machine after upload. You can also use wildcards like salesdata.csv to upload multiple files. Get download files from stage back to local. This is the opposite of put. It pulls files from an internal stage back to your machine. You can see the code in our conversation history. This is useful for auditing, backups, or reprocessing data. Let me know when you're ready, and I'll walk through SNOWPIPE next.
The next section is copy into different modes and use cases. Can you go over that?
Absolutely. Let's dive into the copy into command and its different modes and use cases. This is a key part of loading and unloading data in Snowflake. 3, copy into modes and use case. What is copy into? The copy into command is used to load data from a stage into a Snowflake table, or unload data from a table into a stage. It's super flexible. You can filter files, validate, handle errors, purge, and more. Use case 1, loading data from external stage. Let's say you have files in an S3 bucket connected through an external stage. You can load them like this. You can see the code in our conversation history. You can also use a pattern to load multiple matching files. You can see the code in our conversation history. Use case 2, purge equals true, delete files after loading. You can see the code in our conversation history. Deletes the file from cloud storage only after a successful load. Only works with external stages. Be careful. This is permanent. Use case 3. Validation mode. Check errors without loading. You can see the code in our conversation history. This is for data quality checks. It parses the file and returns errors without loading anything. Options include return all errors, return once error, return errors limit equals n, return all rows for preview. Use case 4, on error handling. This lets you tell Snowflake how to behave when it hits a bad row. You can see the code in our conversation history. Other options, abort statement, default, stops the whole job, continue, skips bad rows and keeps loading, skip file, skips entire file if it has any errors. Use case 5, force true, reload same files. By default, Snowflake keeps track of which files have already been loaded and skips duplicates. But if you want to reload files, even if they've been loaded before, you can force it. You can see the code in our conversation history. Use case 6, unloading data, export to cloud storage. You can see the code in our conversation history. You can also control the size of chunks. You can see the code in our conversation history. Let me know if you'd like to go deeper on any of those options, or should I continue with copy into for JSON files next?
Yes, move on to copy into JSON file.
Awesome. Let's move on to the next section. Copy into with JSON files. Use case. You've got a JSON file, let's say in your S3 bucket, and you want to load that data into Snowflake. JSON is often nested, so you usually load it into a variant column, then flatten it out into structured tables later. Sample JSON file. Let's say the file in your stage looks like this. You can see the code in our conversation history. Step 1, create a table with variant column. You can see the code in our conversation history. Step 2, load JSON using copy into. You can see the code in our conversation history. This stores the entire JSON structure as a semi-structured object in the raw data column. Step 3, create a staging table to hold structured values. You can see the code in our conversation history. Step 4, flatten nested items array. You'll use the flatten function to explode each item in the items array into a separate row. You can see the code in our conversation history. And that's it. Your nested JSON is now fully broken out into a structured format. Would you like me to go ahead with SNOWPIPE next?
Yeah, so here when we are loading into stage, we are using FLATTEN, and we are also casting the correct data types, correct?
Exactly right. You're catching the key part here. When you load JSON into a stage table using a variant column, all the data is semi-structured, which means Snowflake doesn't assign strict types like integer or string yet. It's just raw JSON. So when you flatten and extract fields from that variant, you're doing two things. One, accessing nested values using or notation like raw data order ID or item.value QD. 2, casting them to the proper Snowflake types using int, string, etc. This step is super important when moving from semi-structured to structured tables, so you don't end up with generic types or failed inserts. Would you like to see what happens if you skip casting or flattening? Or should I go on to explain SNOWPIPE now?
Yeah, move on to next topic, SNOWPIPE.
Awesome. Let's move into the next section. 5, SNOWPIPE, continuous data ingestion. What is SNOWPIPE? SNOWPIPE is Snowflake's automated data loading service. It watches your stage, usually cloud storage like S3, and automatically loads new files into a target table in near real time without you needing to manually run copy into. Think of it like a conveyor belt. New files land in storage, and SNOWPIPE picks them up and loads them almost instantly. Why use SNOWPIPE? No need to schedule or trigger copy into manually. Supports micro-batch loading, great for streaming-ish workflows. You can monitor and track loads. Supports auto-ingest, real-time notification-based triggering. Hash requirements for auto-ingest. To make auto-ingest equals true work, you need to set up event notifications like Amazon S3 and SQS. Snowflake listens to the queue and reacts when new files arrive. Without auto-ingest, you'd use manual REST API calls to trigger SNOWPIPE. Example, create a SNOWPIPE. You can see the code in our conversation history. This sets up a SNOWPIPE to load any files like m01.csv, mp02.csv, etc. from the external stage. Monitoring SNOWPIPE loads. You can check what SNOWPIPE has done using, you can see the code in our conversation history. This shows when files were loaded, how many rows, and whether any errors occurred. Would you like to jump into Stream C next?
Yes.
Perfect. Let's get into the next one. 6. Streams change data capture CDFINIs. What is a stream in Snowflake? A stream is a special object in Snowflake that tracks changes, inserts, updates, deletes made to a table. You can think of it like a changelog, showing what's new or modified since the last time you queried the stream. This is the backbone of Change Data Capture CDC in Snowflake. Why is this useful? Keep staging or reporting tables in sync with the source. Feed changes into downstream ETL pipelines. Avoid reprocessing the entire table, just apply deltas. Types of streams. Standard stream, default, tracks all changes. Insert, update, delete. You can see the code in our conversation history. Append-only stream tracks only inserts, ignores updates and deletes. You can see the code in our conversation history. Stream metadata. When you select from a stream, Snowflake gives you some automatic metadata columns. Column, description, ISO, metadata's action, insert does update, true equals updated row, false otherwise. So if an update happens, you'll see 2 rows, one delete for the old row, one insert with isUpdate equals true for the new version. Example workflow. Let's say you can see the code in our conversation history. Now simulate changes. You can see the code in our conversation history. Hack. Apply changes using merge. You read from the stream and apply the changes to your target table. You can see the code in our conversation history. That's your full CDC logic. Next up, should I walk you through tasks and scheduling stream processing?
Yes.
Awesome. Let's keep going. Tasks, automating stream processing. What is a task in Snowflake? A task lets you schedule and automate SQL operations, like running your merge logic on stream data. It's Snowflake's way of doing orchestration inside the platform. Think of it like a built-in scheduler or a lightweight job runner. Example, create a task to merge stream data. This task checks if the customer stream has changes, and if it does, it runs a merge into the target table. You can see the code in our conversation history. Then you start the task with, you can see the code in our conversation history. From then on, it runs automatically whenever there are changes in the stream. What else can you do with tasks? Chain multiple tasks together like a DAG, set time-based schedules, e.g. run every 5 mins, call stored procedures, handle multiple streams in a single controller task. Bonus, stored procedure for reusable merge logic. Instead of putting your merge logic directly in the task, you can wrap it in a procedure. You can see the code in our conversation history. Then the task just becomes, you can see the code in our conversation history. That keeps your logic modular and easier to maintain. Want to go next into zero-copy cloning?
Yes.
Great, let's move on. 8. Zero-copy cloning. What is it? Zero-copy cloning is one of Snowflake's most powerful features. It lets you instantly create a copy of a table, schema, or database without actually copying the data. Instead of duplicating rows, it creates a pointer to the original data. That's why it's zero-copy. It's super fast and very storage efficient. Key points. Clones are independent objects. You can modify them without affecting the original, but initially they share the same physical data behind the scenes. Only new changes take up extra storage, like a copy on write mechanism. Why use it? Test changes on real data without impacting production. Snapshots for backup or audit. Promote data between dev, test, prod environments. Instant data recovery. Clone a table. You can see the code in our conversation history. Now, customer data clone is a full copy of the original, but without any duplicated storage. Clone a schema. You can see the code in our conversation history. Every object in the schema is cloned, tables, views, etc. Hash, clone a whole database. You can see the code in our conversation history, even faster than schema-level backups and great for sandboxing. Good to know. Cloning works with permanent and transient objects, but not with temporary tables. If you drop the original object, the clone still works. It becomes a full copy. If time travel is enabled, you can also clone as of a past point in time. Which leads right into the next topic. Shall we go on to time travel?
Yes.
Awesome, here we go. 9, time travel, query and restore past data. What is time travel? Time travel lets you query, restore, or clone data as it existed at a previous point in time. Even if someone deleted or modified a table, you can go back and get the older version within a defined retention period. This is great for undoing mistakes, auditing changes, or recovering lost data. How it works. Snowflake keeps metadata and history for data changes behind the scenes. You can access that using special AT or before clauses. The retention period depends on your account's edition. Edition, default retention, max retention. Standard 1 day, 24 hours, 1 day. Enterprise plus 1 day up to 90 days. You can also override it per table using. You can see the code in our conversation history. Querying past data. Use a specific timestamp. You can see the code in our conversation history. Use a relative offset in seconds. You can see the code in our conversation history. Or use before to get state right before a time. You can see the code in our conversation history. Restoring dropped objects. Even if a table is dropped, you can bring it back. You can see the code in our conversation history. Clone from the past. You can use cloning with time travel to get a snapshot. You can see the code in our conversation history. What if the data is too old? If you go beyond the time travel window, it fails with an error. That's where Failsafe comes in. Failsafe, a 7-day backup period after time travel ends. Only Snowflake support can recover data from Failsafe. You can't query or preview it. Only available for permanent tables, not transient or temporary ones. Ready to move on to the final section. Table types?
Yes. Yes.
Great. Let's wrap this up with the last section. 10. Table types in Snowflake. Why table types matter in Snowflake. The type of table you choose affects data retention, cost, failover capability, and session visibility. There are 3 main types: permanent table, default. You can see the code in our conversation history. Default type, when you just say create table, supports time travel and failsafe. Ideal for critical data that must be recoverable. Transient table. You can see the code in our conversation history. Cheaper than permanent tables, supports time travel, but no failsafe. Great for staging, intermediate, or temp data you don't need to recover after time travel expires. Temporary table. You can see the code in our conversation history. Visible only to the session that created it. Disappears after the session ends. No time travel, no failsafe. Ideal for intermediate queries or scratchpad use. Summary, comparison, table type, time travel, session scoped, lower cost, permanent, temp friend. And that's the full walkthrough. Would you like a clean export of all this as a markdown or PDF? Or maybe a diagram summarizing the flow?
No, all right. Thank you. I think that's it.
You're welcome. Glad we could go through it all. If you ever want to dive deeper into any part or turn this into a polished doc or visual, just say the word. What are you planning to do with this guide? Training, documentation, or personal learning?
Just a personal training.
Nice, that's a great use case. This kind of hands-on, structured walkthrough is perfect for post-op training, especially for devs or analysts just getting into Snowflake. If you'd like, I can help turn this into a clean training handout, cheat sheet, or even slides. Want me to whip up a summary version for distribution?
No, thank you.